In this video, we're going to talk about the concept of buffers. Buffers are nothing more than really it's a mixture of two chemicals which resist small to large amounts of acid base. Okay, so it's a specific solution, and we're going to be talking about solutions as we're talking about acids and bases. It's a solution of two chemicals, and they're very intimately linked. The two chemicals need to be an acid and its conjugate base, or a base and its conjugate acid. So in these cases, buffers are not going to be involving strong acids or strong bases. Okay, we're going to be talking only about weak acids and weak bases because all of this is based upon equilibrium. We need reversible reactions. And if we don't have a reversible reaction, if we get an acid or a base to completely ionize, it's not going to work out. Okay, we need Le Chatelier's principle. We need this dynamic equilibrium to help us resist and small to medium to large amounts of acid base addition to the solution. All right, so let's look at a weak acid and its conjugate base. How about let's look at carbonic acid. All right, this has a pretty low Ka, so it's not going to ionize. It's a weak acid, H2CO3, and it's going to give off one proton and form the bicarbonate. Okay, it's going to form that, and as we can see, this is an acid, a weak acid, and this is the conjugate base. Now, if we make a solution that has both of these ions in there, both of these compounds in there, let's say we make a solution and we put in it, half molar carbonic acid and half molar sodium bicarbonate. Okay, notice we have the acid, and I'll do this in red, and we have the conjugate base, because remember, all sodium compounds are soluble, so this will readily dissolve, and you're going to have this bicarbonate ion in there. And these will interact with acids or bases that are added and will resist a pH change. So let's take a look here at what we're talking about. All right, H2CO3. All right, it's going to react with water. So let me put water here. And we have a reversible reaction. We're going to get HCO3, the bicarbonate ion, and hydronium ion. Okay, so here we see the reversible chemical equation. And notice we have carbonic acid here, and we have the bicarbonate here. Now, think of it as a solution right here. Now, if we add acid, we increase the concentration here, and it's going to push this in the direction to release the pressure on the system, and it's going to form more of the unprotonated acid. If we add a base, it's going to force it in this direction, and the acid's going to be produced in order to resist and kind of neutralize that base production. Okay, so as you can see here, this will buffer the addition of either an acid or a base. Now, if you can see the adding the acid will push it in this direction. Let me try putting that in a certain color here. Add acid. It's going to push back in this direction from Le Chatelier. Okay. Now, what about, in this case, we have an acid, so obviously water is going to act as a base here, okay, because it's receiving the proton, okay. So this is actually a base in this particular reaction because it receives the proton. Now, if we add a base, we put that in a different color. We add a base. It's going to push it, Le Chatelier is going to push it in this direction. And we're going to form more acid, and that acid's going to counteract the base that's added. So this is what buffers do. They use the principle of equilibrium, the fact that this is a reversible reaction. So if you add one instance, it pushes back in the other direction, causing a shift in the equilibrium and not much of a change in the pH. And you do the opposite, you add a base, it's going to cause a shift here, producing more acid, and you're not going to get a overall change in the pH until both of these chemicals are used up. Once they're done reacting, once they're pushed to their limit, they can't do any more. And then when you add any more acid or base, depending on which way you're going, it's going to have a violent change in pH. It has a buffer capacity. It can only do so much. And this is something your blood does. Your blood is highly buffered in your body because your body is very susceptible to very slight changes to pH in your blood, or either acidosis or alkalosis, right? So blood must maintain a very small range of pH or you're going to have some physiological problems. And as a result, it's buffered.